schools, I mean, you're running, one kit's $500.
Because I know how to look
one
at
kid
the
is two
Lego
kids.
website.
Yeah.
12, right? And it just starts to really add up, right? So
Have you seen the robotic?
You find that
Robotics, yeah. I have a EV kit.
the
Oh, yeah.
teachers are keen
I'm planning
to
today
get
to
the
do
robotics
robotics
kits out
to
and
build like
all depends on who you are, right? And that's, again, what I'll talk about tonight, like to the adults, which is, I mean, the program is the teacher, right? So if the teacher moves,
I see.
the program dies,
That's really cool.
right? So, and that's one of the things, like, that's quite interesting, right? That people don't maybe understand. Like, Vanya used to be like the robot school.
Yeah.
right.
Yeah, I think
Doesn't
I
exist
had more
anymore.
Lego. I didn't follow
Right.
instructions.
So,
They're
Built
Brooklyn
whatever.
and
Yeah.
is
So
that
when I
Janet
do them a
Jensen?
set sometimes, but
Yeah.
probably smaller
She was
sets,
one of the
smaller
robots.
pieces of
Yeah.
it.
She's
Yeah.
I take it apart and
so
then I
is it going to be back again or not, right? If no staff member picks it up,
Yeah.
it
My friend
disappears,
got me
right?
Called, I think
I,
microblocks or
I run a
nanoblocks.
coding club
So
at
they're like
Brooklyn.
little
Yeah.
mini
So
Lego.
we do
So
scratch
like
and
every
stuff.
single piece
So
is like.
I have another question.
curious
Uh-huh.
about,
Doing
getting
robotics
into the
full time,
robots.
Yeah.
how we play with that set.
I'm not sure on what grade it's
Which
that's
set? The
for.
Minecraft
All
one?
depends on the
I don't know.
platform.
You have to talk to Julian. He's the owner.
I think we've got some
Just
easy
volunteer.
fees in Brooklyn.
Yeah.
I guess it's how much support you give the kids. If you can,
I have a
give
Lego
them
set
something
that's
pre-made or
Yeah.
older.
get them to
I
build
have
some
the first Lego
specific thing
Minecraft set.
and
They've
they
ever
could
made.
learn
Okay. Really? How old is that?
Yeah.
line tracking or
I can't
whatever.
remember. Something.
And every, like I say, every
I bought
platform's
it
different,
something
Right.
you know, and I've worked with all the different platforms.
around-
So,
So, I'll stand about here and I'll wave about
It was
there
probably
because
7.
I
can't
am
remember.
live
I'm
streaming this,
10
just so
right
you
now,
know.
so-
The camera is focused on the TV here and on Steve, so if you don't want to be on the internet, stay out of this zone of influence, because we may have some people joining from Parksville and possibly from Hornby Island. So we'll see what happens, and besides, it's will give me an excuse to play with all this nice technology. So we'll get started. I'm Julian. I've set up the maker space here called Make It Zone. We're interested in robotics and 3D printing and laser cutting, all sorts of stuff, so I can give you a tour later if you haven't seen it. But what I also want to try and do is support robotics in the wider sense in the Comox Valley, and our school district, who Steve is very influential and also the guy who's done a lot of stuff here. I'll let him introduce his exact role in a minute. Was kind enough to come out to try and explain what is happening in School District 71 this year for robotics, and also some of the changes that are happening with some of the robotics events, I'll call them events, with some of the robotics systems that are more popular in the school districts, and there's some pretty good, not good, well it's good and it's also big news about how some of the events are changing and more is coming to the island. And for those who are interested, who want to do stuff outside of the school district, well, I'd also like to try and build up community outside as well for adults, for people who have graduated out of the schools, the secondary school system, primary school system, elders, everyone. Robotics influences so much of our life, and they seem so mysterious, and yet they can be so much fun. There's a lot of opportunity for creativity, for problem solving, for all sorts of stuff. And some of us, at least 2 people in this room, are making their living partly out of using robots. There is 2 businesses in this building that use robots to make money. So we can talk about that later as well. But I'll stop talking because I can keep yabbering for a long time and hand over to Steve. Thanks, Steve.
right. So my name is Steve Klassen, and I'm a shop teacher originally. So I've been teaching for about 25 years. And I have basically gone through anywhere from woodworking, metalworking, teaching electronics, back in the days where there was really not a lot of electronics out there other than very simple parts, to nowadays where we're now dealing with Arduinos and microprocessors and things, and coding in the schools and stuff like that. So I'm just going to start and just go through a couple different slides here just to get you going, to get a feel for kind of what's happening in the school district. Okay, and then we'll talk about it later. So first off, the history of robotics. It's been in this school district. It's been going since about the 1990s with what's called Skills Canada. And Skills Canada robotics was basically you built from scratch. Now the problem is that it was really expensive. So if you look at the bottom slide there, you're going to see this great big giant robot that had wheelchair motors with bicycle wheels, and it was some type of robot that was going to pick up things and shoot things, right? But it's made out of wood and stuff. But at that point in time, there was no real systems and structures that were there to actually build things. right? And then up top left, that's a FIRST robot. Okay, so basically we've been going since the 90s with Skills Canada. The programs of various sorts and all over the school years they've changed. A lot of times it's dependent on the teacher. So different platforms come and go. So you'll have Lego Mindstorms, you'll have Vex IQ, you'll have Vex, you'll have the Skills Canada, you'll have FIRST Robotics, and it's all a lot of it teacher dependent, but it's all in the schools. Vex Robotics started about 2009, where within the school district we started to compete, and we held our first tournament. And then the Skills Canada still is present today. So there are teams in the district that still do that. And then finally, the FIRST Robotics has started in the last couple of years, right? And if you think of the different robot systems, FIRST Robotics is like the pinnacle of all the robotic systems, okay? So here's a couple little short video clips. I'll probably pause them partway through. This was one that was done about 2009, 2010, and this is at Vanier. So simple robotics can be just putting a mask on and using buttons and controlling. So learning really simple code. So these kids had to actually program themselves by little LEDs to say, this is what I'm doing. This is SumoBots, where the intent was to push just other robots out. That was a really simple version as well. It was tethered, but that's where we were, right? Back in the early, kind of mid 2000s, right? So that was syringe robotics. You couldn't afford pneumatics, so we used syringes to actually pick things up, right? So you see these kits you can buy online. A lot of it's laser cut now. That was underwater, okay? So it's just a Cat5 cable, and inside there was just basic little motors, right? This was BattleBots. We all like BattleBots. The problem with BattleBots, they're expensive, so we had to do them tethered. But this was like, the kids loved this. And then we started getting into Vex Robotics, right? So it was really easy to program these robots to actually do what you wanted to do. And there was really simple programming languages, right? So we had a competition where you had to actually go blow something out, right? So oops, this one's a bit longer than I thought. So, okay, and then finally this is Vex Robotics, which is the actual Vex program where there's competitions all over the world and worldwide, right? So that's what this is. And this was from years ago again. This is one of the first competitions. And then finally you have Skills Canada Robotics, which is home built from scratch, everything yourself, right? But if you look at it, it's actually not robotics. It's remote control stuff, right? So that's kind of just one quick little video. This is Skills Canada Robotics now. So this is about a 30-second little clip. And you can see in there, I don't know if you can see really closely, maybe on this one up here. Whoops, let's move my mouse right there. This one here, there's actually whoops, that's not gonna work. There's 3D printed parts and stuff in there. So people are using the Vex Robotics system, but they're building other robots with it. So when I play this one, okay, so listen, just watch how fast these things fire. So, and they were picking up little soft golf balls, and then you can see them just chucking and scoring, right? So this was last year's game. The team on the left, which is Isfeld Robotics, they, in the final match, they actually sadly lost. Otherwise, they would have went to the national competition in Halifax, right? But that's kind of what the Skills, whoops, there we go. That's kind of what Skills Canada Robotics is now, where you can use multiple systems. And then finally, this is the big one, right? This is big money, FIRST Robotics. Just to enter this competition alone is $5,000, right? So a lot of these things aren't cheap, right? So here, I only run this for 30 seconds, but you can see how fast these go. And you get perspective by the people, how big these robots actually are, right? So you can see, these are big things. These are 3 feet by 3 feet by, and when some of them go up, they're 7, 8 feet tall, right? But this is full, and this is high school kids doing this, right? So grade 10, grade 11, grade 12 are building these things, right? So just gives you a perspective of how fast they go.
Kids from our district?
Our district right now, so if I just pause this, whoops, I'm gonna move that back. That there was one of the matches where kids from our district were competing. All right, so basically the first is the big one, right? So now when you start looking at all the different platforms, you can see where it actually goes to, right? So the platforms basically in our school district right now that are being used, there's the top left is Vex EDR, so the Vex robotic system. Okay, the top right is Lego Mindstorm, right? And there's Lego Mindstorms, there's the Lego EV3s. And then the bottom is what's Vex IQ now. So if you look at the Vex IQ, which is the bottom one, and the Lego, they kind of compete against each other. They're about the same level, right? Both of them can be done grade 6, grade 7, grade 8, right? But after that, you kind of want to move up to a different system, okay? So that's kind of what that is. And even Lego, the Mindstorm, that can be down to grade 4, grade 5, right? They're built really simple, right? So that you can easily put them together and have success within 1 hour, right? Yes, sir.
In grade 3 and I have Lego mine.
Do you? Yeah. It's great to work with, isn't it? Okay. So,
Including what my dad does as well.
yeah, that's cool. So basically the top left one, which is the Vex EDR, is harder because now it's all metal, you're screwing it together. It's more to make it program and actually make it work. Okay, there is simple drag and drop, like Scratch type software for it. So they make it really simple for the software at the beginning, but then you can get very sophisticated softwares to run very interesting things. Okay, so there's that. The next one here is STEM programs and what I call the ebb and flow. So throughout the history of the Valley, when it comes to robotics, and I'm going to say electronics and robotics or STEM programs, they've really changed, right? And they're always centered around a teacher. So if a teacher moves on, there's times where a program might actually disappear, right? So for example, I used to teach at Vanier, and Vanier had a robotics program before me, robotics program when I was here, and then I left, and it kind of just slowly changes because the person changed. Nothing wrong with that. It's just that their interest in stuff changes, right? So they're just not doing competitive robotics, right? They still are, because things like this are what are being built, right? And so yes, you have kits that are Vex IQ, Mindstorm, right, and that, but this is now Arduino, right? And it does the same thing. You can buy a kit. So if I go back a slide here, you can buy these, and the top left one, Vex, I know for a fact that's about $800 what you see there. Okay? Well, I got this thing right here, and for 20 bucks, I have an Arduino, I have a motor driver, I got some motors off of Amazon that cost a couple dollars each, right? I have the same sensor that one has. This one costs $3 off eBay. Theirs costs you 30 bucks, right? So you can build things really cheaply, right, and have the same level. It's just that these are meant as a nice kit, really simple to put together, the instructions. This is just from scratch. And it's interesting because when you look at something like this, you go, this is what's being done in the school, right? It's being laser cut. All the high schools have laser cutters, okay? There's 3D printed parts. Every school, the high schools have 3D printers, right? So there's schools that have 6, 8 of them in one classroom, right? And you have teachers that are teaching this type of stuff. So it's all there, it's just that it's not a kit. And when you start looking at things, you go, I'd love to buy this for my whole program, but the money's just not there to actually buy it for a whole class. So a lot of teachers like myself that are shop teachers that have the background in electronics and robotics through schooling, a lot of us opt for this because to us, this is where the learning is, because it's your hands-on fabricating, right? You're drawing in 3D, right? And you're using Inventor, or you're using Tinkercad, or you're using, it just went on me, my other one, that Fusion 360, right? There's so many different there's so many different programs that you can use to do this, right? But there's little things like that, so they're slowly changing, right? There's a simple Vex robot, right? And again, when this was out there, this was about $500 at the time, what you see here, right? And that adds up, because you can't do much more than build this, right? But you can program it, and you can make it do everything that you want it to do, okay? And there's no difference between this and, for example, your EV3s, right? Same programming, right? Same type of coding, same learning skills, everything else. It's just a different way of doing it. This is limited. The motors are only so strong. These motors are a lot stronger, so you can do more with it, right? So I'm just going to put this down here, and then I guess I'm getting off track here a bit, but when you look at this little guy, this is Otto, Okay, and I think, no, I don't have a battery for him. Shoot, I forgot the battery. So he basically is one that you can use, and again, it's $25. You 3D print it all, right? You put it on the ground, you code it with Scratch or different softwares, and it will dance, it will do whatever, it'll walk, it'll turn around. You can have it beeping. You put your hand in front because the eyeballs are actually an ultrasonic rangefinder, right? And it will just go. And there's a really simple way of doing things. And again, have students draw it first, 3D print it, right? Code it, and there's a whole progression, right? So this is one of the ones that we're implementing this year, some people in the high schools, is there's a simple grade 8 or grade 9 project that you just put it all together. And what's interesting when you open it up is, and oh, maybe I won't do it. Yeah, I will. There's the exact same Arduino inside there, right? And there's the same eyes, right, or ultrasonic rangefinder as this one here, identical. So the only difference is there's a motor driver that drives 2 wheels. This one down in behind here, and it's a little hard to see, but we'll do this, there's just 2 servo motors, right? And then there's 2 servo motors this way. That's the only difference, right? So you can develop a whole program, you know, just around this stuff, and it's quite cheap to do, right? So kind of cool. Just getting back into here. So basically, you know, in the elementary schools, we've heard from the audience here that there is some Mindstorm, and yes, Lego Mindstorm is out there.
Put them on
Yep.
the table
Oh,
so we
sorry.
can see them. No,
Yep.
it's all good. I'll
Okay.
just put them here so people
Yep.
can see them afterwards.
So basically, there's Lego Mindstorm is in the elementary schools, kind of grade 4, grade 5 right now, right? Grade 6, grade 7, it's a bit in there as well, and it all depends on the school. And then we have what's called the Enter program. And the Enter program is basically meant for grade 6 and grade 7, where if you're a technology-focused student, and it's through NIDES Navigate. And basically, it's a program where the kids come 3 days a week, Tuesday, Wednesday, Thursday, but on Mondays and Fridays, they stay at home and do homeschooling, right? And do their online courses, okay? And then there's Enter 2, which is grade 8, grade 9, and I was just in there today. And again, it's 25 kids. They're all technology focused. They're working with 3D printers. They're working with all sorts of laser cutter, all sorts of these tools and equipment at that age, and drawing in 3D, right? And again, working towards robotics. Yes.
I'm in grade 5 and grade 6.
Yeah.
I might be thinking about doing the program.
Yeah, it's a good program. You'd really enjoy it. Okay, there's lots of kids been through it, and when we talk later and we start looking at some of the robotics teams, you're going to know that all those kids are actually Enter kids. Okay, so there's Enter 2, and again, they're doing some really cool high-end stuff at grade 8, grade 9, right? Because they're exposed to all this technology. Individual school programs is kind of interesting because one of my audience members here, you did physics engineering, and it was a combination of physics 11 and hands-on. So we applied the physics knowledge to hands-on stuff. So we were doing robotics, we were doing electronics and programming Arduinos. We were doing bridge building, all sorts of different things within that, and it applied physics and engineering together. The pinnacle one was MEEP 12, and it was called Math 12, Engineering 12, English 12, and Physics 12. And it was a really cool program because the kids actually took English 12, but they were all technology kids. So the English teacher actually made English around technology, not stuff like Shakespeare, right? Which those kids didn't relate to necessarily. So that was a really neat program that ran for a while. And then of course there's electronics, robotics, 9 to 12 in the district or in the schools. There's programs called iMaker or Maker, right? And basically it's the maker movement, right? Where kids go in and they learn technology. They're using 3D printers, they're using the laser cutter, they're using CNC routers. All 3 schools have CNC routers. All the schools, as I said earlier, have 3D printers. All 3 schools have laser cutters, right? So there's a lot that's going on now in the schools that wasn't there 5 years ago, right? So pretty cool, but again, it ebbs and flows with who the teachers are. So as someone like myself moves up and out of the school, someone takes my place and they're not necessarily going to do the same as me, right? An English teacher comes in, teaches English 12. The English teacher leaves, the next person comes in, teaches English 12. Here, it's different because it is an elective course and it's a specialty, right? Not everybody does this, okay? The next one is kind of robotics clubs, and it's quite interesting because over the years, all the schools here had robotics clubs in one shape, form, or another, right? So the original schools were actually Vanier and Highland. They had the robotics clubs going back before 2000, right? And then when things changed and Vex Robotics came on in 2009, it was still Vanier and Highland. And then Isfeld had a team. And then next thing you know, Nides had a team. And then things come and go, right? That ebb and flow. So it all depends. And these are just the top picture there is the Nides team that actually went to the Worlds last year. So that's right off their Facebook page, 7842. And then the lower one is the Isfeld kids in their first year of doing it, right? And that's not even all of them. There was about 18 of them. Okay, that's just the photo that I found for tonight. But, so there's about 15 to 20 kids that were at Isfeld, 15 to 20 kids that were at Nides that were all competing competitively. And this is specifically for Vex Robotics at this point in time. But remember, there's Skills Canada Robotics. There's First Robotics, right? There's lots of different programs out there.
So Steve, maybe you could just pause for a second, because that's me as a person coming into understanding robotics in North America.
Yeah.
I did robotics when I was at university, so this is going back into the dark ages of robotics when you built everything from scratch yourself.
Yes. Yeah.
And it was a mouse robot that solved like a maze.
Yeah.
Like literally, you had to get to the cheese in the middle.
Yeah.
And the software was so archaic and primitive that if you managed to make a robot to get to the center, you were deemed to be one of the best in the world.
Yes.
Let alone, so things have come along so far in such a short time. But then as you're entering, like, what is first? What is skills? What is Vex? What is IQ? What is EDR? Are they all the same things? If you don't mind, just expand on those a little bit.
Well, I mean, each one is very different, right? So in robotics clubs themselves, Vex Robotics is, as you showed earlier, that this system right here, right? So, and it is actually a worldwide competition, right? So this system here, when you see some of the videos in that, it basically, there's 15 seconds of autonomous where the kids have to autonomously actually go and do something, right? And then there's a minute 45 where the kids drive. And it's amazing the coding levels and the sophistication of what they can actually get these things to do, right? Picking up cubes or throwing balls and now there's vision sensors and all sorts of things on this, right? The Skills Canada one, as I showed in the video earlier, it was the true, I want to call it the purest robots, right? It was from scratch. And it wasn't until recently that they actually allowed this system here to go in, and you could use this microcontroller and the remote to use in that system.
And that's called the EDR system with the middle.
This one's the EDR. I didn't bring a V5.
No, that's fine.
Yeah.
I mean, like, there's also the IQ, and that's a more plastic.
Well,
yes,
it's the lower one, the Vex IQ, right? And again, they've got a worldwide competition as well, right? So some of the stuff is meant and geared towards competition worldwide. Purely, like from my point of view, like everybody's at different levels, and I think my next slide is talks about that. But basically, right now, so robotics clubs happen. They are teacher dependent, 100%, or volunteer dependent. If you're going to run a robotics club, whether it's Vex Robotics, First Robotics, you have to know minimum 8 hours a week is going into these groups right now, at minimum. Okay, so a lot of times what we would do is we'll run kids throughout the school day, before school, lunch, during class, and then after school till, I'm actually missing a robotics thing right now at Nides at Highland till 8 o'clock tonight. They've been running since 4, right? So they basically just keep going because you need that much time. The nice thing about the Vex Robotics is that there's multiple competitions. So you start the season in now, right? And the first competition in BC is in middle of October, but it goes all the way into February. And so what happens is every 2 to 3 weeks, there's another competition. So you can actually take your design and change it and see and try and improve it, right? Whereas the Skills Canada robots, it is one shot, and you go there and it's one shot. And if you win, you move on. If you lose, you're done, right? So there is different ways of, or levels of how it's organized. First is the same thing. You go to the big first event down in Victoria in March, and from there, then you would advance on, right? So next up, I guess it's more about the tournaments and competitions. So the different clubs and programs compete in tournaments and competitions, right? So it all depends. Sometimes you can do like Vex IQ, you can do it in class, and then you could go to competition. And you really don't, Vex IQ is a lot easier. The Vex EDR, which I just talked about, you need to do it outside of class, right? It can be very expensive. That's the big thing that people don't realize. If you want to get into actual competitive robotics, first off, a Vex robot, so this system here, and the newest system called V5, to get a competitive robot is about $2,000, right? That's what it's going to cost you to be competitive. Now that's just the robot, okay? If you want to compete, then it's $200 just to register for the year. So you pay your $200. Once you paid your registration for the year and you want to go to a tournament, then it's another $50 or $60 to go to the tournament. So it starts to add up pretty quick, right? So you'll find teams are fundraising and things like that because it costs a lot, right? And every year parts break, right? So you got to replace them. And then new parts come out, so everybody wants the newest thing in life, right? You know, so we have to replace and buy new parts. This one's actually decently cheap compared to first. So when you look up here on the slide, the very bottom one, which is hard to see on the camera, is the first event again. Like the entrance fee alone for that is $5,000, just for that. The robot, they give you, you know, if you're starting out, it's a lot cheaper, right? So they give you $1,000. But basically the robot is still another $5,000. So now you're at $10,000, right? And then you have to travel, and then you might need different parts. Now you're at $15,000 to go to one event, right? But it is the top pinnacle. This is teams where, with FIRST Robotics, like NASA has a team. The difference between them is the Vex EDR, or Vex Robotics. It's all students. So you usually have 3 or 4 students on a team, and you have a coach. But the coach isn't allowed to be involved, right? Once the tournament starts, you're not in the pits, you're not helping them build anything. You can coach them, but you can't do anything with them. First incorporates engineers and things. So they encourage people to come in and help support the kids. So it's more of a community thing, right? So Vex has got four kids on a team. First might have 15 or 20 or even 30 kids because there's a lot more to it. But there's a lot of expense, right? And every one of these has a different level of learning, right? And what you want to get out of it. So tournaments also, you're always looking for different kids will have different levels of competitiveness. So I have groups of kids right now that they just like building robots. And they love to go to a tournament. And they're happy if they win one game. And they're so excited because they won a game. And it's all about learning. And it's all about them. You got to think sometimes, what's education about? Is it really about winning in the end? Or is it really about us working together and teaching kids how to collaborate, right? And ideate and come up with the ideas and learn to work together. All those types of things, right? Problem solving skills. That's what's really important, right? And they gain all that through this, right? So that you do have the kids that just come out and say, I just want to build robots and I'm happy. And then you have the competitive people that they're there to win. And there's a balance there, right? And you have to wage your way through that, right?
Steve, just go back just a
Sure.
second. Also, first, you're talking about, first has multiple levels as well too, doesn't it? Because you're talking about the high-end.
I've taught, yes, like within FIRST, there's FIRST Lego League and FIRST Tech Challenge and all those things.
And that's more aimed at the younger kids.
Yeah.
It's still expensive, but
Yeah.
not to the same scale.
Yeah,
And I think that the mentors are allowed to have more support than the
Yes.
one. Yeah, okay, cool.
yeah. The biggest thing is there's so many different platforms out there now that you kind of pick one and you kind of want to stay with it,
Yeah.
right? So in our district, we've kind of just gone with, we're kind of migrating over to the Vex one at the moment,
Yeah.
but it may swing the other way someday, right?
Except
So,
for your,
and it's a big investment.
oh, absolutely. Except for
Right.
perhaps like I think the district just did the big, I'll call it the big Vex, not Vex, big first for the first time last year, and that
Yeah.
was a total custom everything build, and that
Yeah.
was amazing. If there's an opportunity to see it, which we'll talk
Yeah.
about hopefully later, you guys should go out and see it because it's amazing.
It's pretty cool. So when it comes to tournaments and competitions, there's also some changes. So what happens typically is you compete within your region. So let's say BC, and you win at tournaments, and there's different types of awards and things. And if you win certain awards or win the tournament, you would advance to the provincials. And if you're at the provincials and you win at the provincials, you would advance to the worlds, right? And then you have a chance to be the best in the world. So here in BC, what's happened is, I guess they needed to change where the location of the provincials was. So what we did is we suggested, well, let's run it on the island. And I guess things happened, and next thing you know, just based on the sheer number of teams in BC, they've just decided to actually break up BC and have a mainland regional or championship and an island one. So for the first time ever, we actually have VEX Robotics Island Championship. So whoever on Vancouver Island competes, and if they win at this championship, they actually go directly to the Worlds, right? So that's kind of a big change. So we're actually hosting it here in the Valley. So, and that's going to be February 29th, 2020, and it will be at Marquisville Secondary School. And that's really cool because it will showcase all the best teams on the island, right? And again, the winners there go on to the Worlds. And that's where everybody's going to be coming. Those that win are going to be coming to the community and going, can we collect your bottles? We're going to be grocery bagging. We're going to be doing all sorts of things because there's a big cost to that, right?
And that event will be open to the public?
Oh, of course. Oh, yeah. No, we'll have it on the radio
Yep.
and in the newspaper and things like that. This is the big one. So that's very cool. And, if you're interested in the tournaments, it is really neat to actually come in and help. We're always looking for volunteers, right? And it's simple jobs. A lot of times it's the parents that help out, right? Running concessions or just sheerly, we call them the queuers, the people that run around and like to yell at kids and tell them to get somewhere. So it's when you come to a tournament, it's quite an elaborate setup to have 70 matches in 5 hours and 4 teams on a court at the same time, and it's all got to be managed, right? So there's always, we're always looking for people to help out.
So what are some of the kind of roles that volunteers might have on there?
Sorry, is that one?
What are some examples of the roles that volunteers would have?
One would be queuing, right? There's always, we need people to actually run the tournament software and things like that. A lot of times it's district people that have been doing it for years, but we don't mind bringing some extra people in to start learning how to do it. We need judges, right? So what we look for a lot of times is engineers in the community. So because when the kids go to get judged, they're judging the kids on their designs. They're judging the kids on how their code works. They're judging the kids on their engineering book. So you have to have a journal basically that says what you've been doing and how you've been doing it, right? So they're judging them on sportsmanship, all sorts of different things. So we're always looking for judges. I am looking for judges for this year. And we also need referees. So we have community members, again, that they've been doing robotics in the past, or they've been doing any sort of role where they know that they can make a good decision and they enjoy robotics. Like, come in, learn the rules, and be a ref.
And you also
Right.
need those helpers just to run things around?
Just helpers. We need schleppers sometimes just to pack up, pull down. And like I say, it's a big day. It takes a couple hours several hours to set up and then take down. So there's always lots of roles for people to do, for sure. Okay. Next was, I guess this goes back to community support. So the Robotics Club needs community support, bottom line, right? At the end of the day, it doesn't run, and I think everybody knows the school system only has so many funds, right? And I think parents only have so many funds. So if you want kids to travel, right, we need community support. That's the bottom line, right? So we do fundraising. So they do different things. I mean, some kids are very successful, or teams, they do bottle drives, right? That's an easy one, okay? Grocery bagging has been very, very productive in the sense that the kids will stand at Quality Foods or Thrifties and bag groceries for the day and explain what they're doing, and they do quite well. So we appreciate anybody that's donated to those kids over the years, because it's going directly to them to travel, right? That's all this is for, right? And making projects is kind of funny. That one I threw in there because there's different ways to fundraise. And when you're a woodshop teacher and you have some kids that have used a CNC router and kids that have used the woodworking machines and the laser, we actually made all the cedar plates for the Tofino Wine Fest, right? And that was a big fundraiser for us. So we took cedar boards and we planed them down, and we drilled holes. I taught them how to do an assembly line, right? So everybody started with a board, and you jointed face side, face edge. You planed it down. You went to the miter saw. You cut it. You drilled a hole. You bandsawed it. You got a little board, right? And then somebody went and ran it through the laser cutter to actually laser their logos in, right? So it's a pretty cool fundraiser that way too, right? But there are all sorts of different things are used for fundraising. Bake sales, they work, but when you're trying to get a big thing, right? We're looking for bigger money. First Robotics is always looking for sponsorships, right? First Robotics is big, and there's a lot of money. So sometimes they're looking for corporate sponsors, right? So let's go to GM, let's go to Weyerhaeuser, some bigger company that would sponsor a whole team, right? But definitely sponsored from local businesses. And the NIDES teams, these guys right here that are in the picture, they went and did a whole bunch of sponsorships from local businesses, right? To be able to afford to go to the States for their competition, right? Grants from organizations, same thing. There's always grant money out there that we always apply for, right? Because again, this is expensive to run, right? And the big one at the bottom, the bottom line is the school and the district, they can't support every program for the funding that they need, right? Every sports team, if anybody's ever been on a sport team, they know, they've had to fundraise, right? So it's quite interesting, you basically got to do that because the music, sports teams, all these places, they have to do it. And I think it's a good thing to do, right, is learning how to fundraise, right? And getting out in the community. The last one is, what do kids get out of it? And where does it lead? This is the interesting one, because I got Griffin here in the audience right now, and I know he went through it, the program, the physics engineering with me, and he's here, in this building, right, and he's working on his own project. So I'm assuming, what he did in high school probably helped him kind of come along to where he is now, right? It just at least introduced him to it. And he's shaking his head right now. You can't see this on camera, but
I'm nodding.
he's nodding. He's sorry, not shaking his head, but he's nodding here, right? So
He is agreeing.
yes, he's agreeing, right? So, so basically, where does it lead? To STEM careers, right? So anything in coding, in electronics, robotics, automation, those of us that watch how it's made, right? Like that's a prime example where these kids go to, like they physically make the robots and the systems that make the products that we all use, right? And we need those people. Your cell phone, right? It's all software, right? They learn coding in that.
Who likes
Right, from
washing
here.
dishes? My favorite robot I know is my dishwasher.
Yes,
I love that.
it's awesome,
My dishes in.
right? But you
Done.
need somebody, and you need somebody to design that, right? Like, yeah.
Washing machine.
Yeah.
It's an awesome robot. I love that thing. I
My-
like to go to the river and beat my clothes against the rock to get them clean.
My favorite one still is when you take a photocopier apart and you look inside and go, how much stuff is in a photocopier, and realize somebody designed that. Like that is just like phenomenal. You go, how do they make all this stuff work, right? But that's where these people come from. And, so the skill sets in there through all this robotics is the collaboration, the innovation, the design, the problem solving skills, right? The mechanical aptitude just to be able to do all this. Yes, sir.
There's a soccer video game called FIFA, and it sort of has really advanced code.
Yes, it does. Oh, yeah. Yeah. And you want to know something? Some of the moves that are done there, how that's done is they actually capture it with the different little balls and things on your arms and your legs to actually capture the motion. It's really cool, right? I put this last one in, the very last line, because it's kind of hits home with me with lots of kids. So I call this the blast from the past. So this is Matt, Mac, and Emily. And they were part of the STEM program at Vanier when I was there. And what was really cool with them is they started off and they did the VEX Robotics, right? And then they did Skills Canada Robotics, right? And then you go, and they were in physics engineering, and they did the MEEP 12 one. And then, they graduate and they go on. Well, I came upon them this summer, and I went out for a Comox bakery, date with them, so to speak. And, well, what are you doing nowadays? And the first thing was, you inspired me. I went off to engineering, and I went to Waterloo, and, next thing you know, I got a co-op. Well, where? Well, Tesla.
Nice.
Right? And so he says, so I went and did my co-op at Tesla through the university and went back, finished up at university, and they offered me a job. Right? So here is one of my kids goes right through the programs, and he's now working at Tesla for a lot more money than I make. Right? And he's 23 years old. right? And the next one over, which is Matt, Matt went to Lockheed Martin, right? So he did his internship there. So he was working, and he wants to get into aerospace, right? And again, he started off in that program. Emily was slightly different. I mean, she went into the military, and last I talked or heard was she's making a decision between, is she going into fighter jets or large commercial or large aircraft, right? But there's just a trio of kids that went through school. They were part of a team, right? They all hung out together, and they all kind of continued on to that path, right? So, and I've got lots of stories like that where you see these kids, and they just start here, and you never know where they end up, right? They become leaders, and they become leaders at universities, right? Or they become conveyor belt technicians in Vancouver, making a lot more money than I am, right? So they all have that one thing in common, though, is that they're all in fields that are all technical, right? So it's pretty cool. So my own personal experience is my son is in grade 12 right now, and he's done robotics since grade 8. And he's done the Skills Canada Robotics. He's done VEX Robotics. He's going to do FIRST Robotics this year. And then next year, he's going to go to North Island College and take their electronics and electrical core program for a year, and he'll probably do the industrial automation up there, right? And then after that, who knows? Maybe he works at a Nuctin down in Nanaimo, right? Or maybe he goes off and he starts at his own company, or it just goes from there, right? So anyway, so that's kind of the overview of everything that is kind of happening. There's a lot there that I talked about, but the bottom line is there's lots of opportunity in the schools to do stuff, right? And there's lots of opportunity in this valley, I mean, as parents out there, if you want to get your child into some of this stuff, yes, to get into EV3 is about $400, I think.
Yep.
About $400 or $500, but that'll last you till a certain level, and then it's time to move to the next thing, right? If you want to get competitive, that's when the big money starts to happen, because that's what it requires. Yes, guys.
I got EV3 $200 off.
Yeah, that's cool.
Nice. Please tell
Just
me
because
about
it had
that.
a
Great.
tiny
Yeah.
scrap
That's, hey, you want to know something? Used robotic stuff is awesome. Yeah. So a lot of times you can buy secondhand stuff, and that's what even the school district will do that. We'll buy like the robotics courts and that. I just bought one secondhand. There's nothing wrong with that. But it is a good system, and there's some really cool things happening in the schools. And just if anybody wants more information, you're more than welcome to contact me.
So as Steve is kind of saying, this is a highlight of what's happening inside the SD71 schools, but there's opportunities, even if you're not part of SD71, I'm saying that for the audience online too.
Yeah.
There's opportunities to come out and see and get demonstrations of the different robotic systems.
Yes.
Via events, public events,
Yeah.
because it's not always clear that the robotics events are actually for the public. Like,
Yeah.
I know it is, but
Yeah.
that's what I've had
Yeah.
people ask me, can I just go along because I don't have a kid?
Yes.
Yes, you can.
Yeah.
And then if we can get some adults who are also interested, they're a good pool of volunteers to help out the school
Yes.
and become mentors or helpers. Or if you guys go, well, I'm not really interested in doing the robots club at school, it's too much, but I'm kind of interested. Well, if your schoolroom teacher doesn't have enough time, you can come here, and we've got Arduinos, we've got the servo motors and stuff.
Yeah.
We could make a set of those little robots like $50. They're not going to be as powerful as these big ones, but you'll still learn.
You're going to learn the same concepts.
So,
There is a big thing, Julian, I think, between people thinking they need to compete.
yes.
I'm not a very competitive person, right? So we can do robotics so many different ways. And over the years, I've done so many robots with kids, and anywhere from the famous one that I like that we built one year was just the pop can chucker.
Yeah.
Okay, and literally, yes, people older might not chuck pop cans. It might be a beer can, but literally it sat there, and we just pressed a button, and and there it was, and away you went, right? But you can do all this stuff, underwater submarines and stuff like that. You don't have to buy these expensive kits.
Yeah,
That's the biggest thing,
and
and
you still do interesting stuff.
you can. And I think for me, Arduino is a big way to go right now because it is so cheap, right? And yes, you can go in a couple of days and buy a kit, but if you're willing to wait a bit longer, I use eBay, right? eBay, Amazon, and you can buy stuff so dirt cheap, right? And I've I want to say I've instructed, I've helped parents over the years with, well, what am I going to get my son for Christmas? And I just say, go buy this kit, go get a breadboard, right? Get some wires, get a couple motors. Here's a whole kit for $75 off of eBay. Just order it in September so you get it for Christmas, right? And then it comes, and the kids have a ton of stuff they can do, right? And basically you can run so many different systems with
If you
that.
guys are interested, I have a box of little computers. We can pull them down. I can show you the all
Yeah.
different ones, and there's some pretty amazing ones for as low as $8,
Yeah.
which is mind-boggling.
It's actually interesting because years ago, we wanted photocopiers because photocopiers were the best thing because they had nice motors and they had gears and they had chains and they had all these really cool things. Now everything's it's all so computerized that there's nothing actually in them anymore that we can really use. The stepper motors, yes, to make 3D printers and that. But other than that, like, we just pull wires out to use wires, so we don't have to buy it, right? But it's very interesting how things have changed. And again, you can, if you're willing to put that bit of extra bit in, just get the kits. Or, sorry, don't buy the expensive kits. Just go and get, you know, and just, like I say, there's my Arduino. It does the same thing as this. $25, $500, right?
And you can program Arduino with Scratch.
Yep. There's so many different ways to program Arduinos, right? And that's the best thing nowadays. There's so many different pieces of software, graphical softwares, hard code softwares. Someone showed me one that was basically like a flow chart, right? And you could have different flow charts of code here, and it would all run simultaneously, which, you know, just, I'm used to, you know, I'm 50 years old in a couple months. I'm used to good old BASIC, right? And 10, print my name, right? You know, 20, input dollar, you know, and just, the stuff's so advanced now. And that's probably the coolest thing, is you can do so much nowadays,
Yeah.
right?
Yeah.
That's what's really cool.
We have another question.
We have another question. What's the question?
Can that smaller robot, like the one that's like
Yeah.
2 legs, can it be programmed and instructed
Yes.
to do stuff like talking?
It can't talk, okay, but you can put different things like, so this one here is quite interesting because it is based on Arduino. One of the things I did, not with one of these, but with this one, is we actually use Bluetooth, right? And you would just pull out your phone and we would literally drive that little robot with our phone. And again, for $25. Whereas this now, we're looking at 500, right? So there is, and again, it's come so far, especially in the last 5 years, it really has. And it's made it much more accessible to people that don't have a high skill set, right? You can learn a lot of this so quickly, right? That's the beauty of it. So,
Any more questions for Steve? Otherwise, we'll wrap up the kind of talking part, and then if you guys want to, we can pull out the kits and actually look at some things, look at some coding, whatever you like to do in the time remaining.
I have one question.
sure.
So you were saying First Robotics is not based on like a kit idea with set components.
Actually, it is. So there are set things that you have to have with First Robotics,
Okay.
right? You can't just use any system. It has to be their
Okay.
specific parts and things like that.
Okay. Was there one of them that there was? It was
Skills Canada.
Thank you,
Skills
yeah.
Canada is wide open,
Okay,
basically.
So for Skills Canada, can you take stuff from kits and bring it in?
Yeah.
Or like where's okay? So it's
Yeah.
everything then.
So you can build, so for the Skills Canada Robotics, basically, and I'll just flip back a couple slides here because I think, let's just go with, let's see, will it actually show one more here. So those ones right there, those are the Skills Canada robots. And they've changed over the years because
Right.
they used to be pieces of, and I mean this, a piece of plywood with some motors that were scrounged out of photocopiers, right? And then they had speed controllers that were meant for remote control cars, right? That's what it started as because there were no systems back then,
Right.
right? And then eventually FIRST came on and all these other systems. But these now, this has become a lot more popular, the Skills Canada, because you can use any system you want. So you can use VEX in
So
it.
you could bring it into it.
But a lot of times the motors aren't quite powerful enough. So you want stronger motors to be able to do certain things, right? So, I mean, these robots here used to be, I remember seeing them like 2 feet by 3 feet by a foot tall and having a 12-volt battery in it and having a 12-volt vacuum cleaner hooked up to it, and they would snuck, just literally suck balls straight up, right? And it weighed 200 pounds, right? Well, those days are gone. Now they're all of a sudden these nice, light, smaller, lighter, faster things with 3D printed parts and that, right? And I guess what I didn't touch on is like VEX here, right? This is VEX for high school. There's a whole VEX for university. And then they don't limit you to just the parts. You now can have 3D printed stuff and that on them. So there are different levels, right? But yeah, there's so many different systems out there. It's just settling on which one works for you. I think that's
That's good.
that's pretty good. So thank you very much. I hope that was informing, right? And yeah, there's lots of cool things going on.
Thank you.
There really is. You're very welcome.